There was a historical dispute between Robert Hooke and Isaac Newton over priority in formulating the law of universal gravitation. The problem belongs to a long history of cosmology, beginning with Aristotle's Earth-centered universe of concentric spheres. Copernicus and Kepler transformed that picture by replacing geocentrism with heliocentrism and by mathematically describing planetary motion. But they did not explain the force that held the system together. Descartes tried to answer the question through a mechanical theory of impact and invisible vortices. In the 17th century, the scientific revolution produced many competing thinkers, and disputes over intellectual priority became common. Galileo's falling body experiments supplied an important foundation by showing that gravity acts similarly on different objects, apart from air resistance. Newton later developed a full theory of gravity in the Principia, where he connected planetary motion with an inverse square force. Hooke, however, accused Newton of taking from him the idea that gravity decreases in proportion to the square of distance from the center. The central question is whether Newton merely completed Hooke's insight, or he deserves priority because he supplied the decisive mathematical proof. Hooke had indeed proposed important ideas earlier, including the attraction of celestial bodies, the bending of straight inertial motion into curved orbital paths, and the mutual influence of planets. In 1674, Hooke suggested that all celestial bodies possess attractive power toward their centers and act upon other bodies within their range. In correspondence with Newton in 1679, Hooke also described compounding tangential motion with attraction toward a central body. Yet Hooke did not provide a universal mathematical demonstration of these claims. Hooke himself admitted that he had not experimentally verified the degrees of attraction and that he was only hinting at a line of inquiry. Newton's contribution, by contrast, was to show rigorously that a force varying inversely with the square of distance could account for orbital motion. Hooke's inference about velocity was incorrect, weakening his claim to a complete theory. Hooke later defended his priority in an unpublished memoir, citing his 1666 lectures, his 1674 publication, and his correspondence with Newton. A comparison of Hooke's 1685 orbital construction and Newton's de motu diagram show that their geometric approaches were closely related. Newton denied owing Hooke the central discovery, arguing that similar ideas had already been discussed with Christopher Wren and that his own earlier manuscripts showed work on inverse square relations before Hooke's 1679 letter. In conclusion, Hooke made significant conceptual contributions to the theory of universal gravitation, but Newton transformed such ideas into a demonstrated mathematical law, which explains why the final formulation is historically associated above all with Newton.